All right, I am looking at, this is CC3. This is section 2.1.9, number 2-83, and looking at A through D, solving equations. I'm going to look at these to make sure we really truly understand the process of solving each of these equations. Okay. So A is negative x plus 2 equals 4 is my start. All right, so remember, solving an equation is just finding out what that variable has to be for this to be true, right? It's what we've done way back. We're looking at any number plus a number, plus in this case, plus 2 equals 4, right? If I started with that and I said, what plus 2 equals 4? You're going to be able to tell me, well, 2 plus 2 equals 4, right? So that's what that variable, but in this case, we got a negative in front of it, so it gets a little trickier. So you may be able to see what's going to go into there to still make that work, a little more complicated. But solving an equation, remember, is only just finding that missing value. So when we're doing that, the idea is if I could get this thing and I put in my equation bar, my equation line, just so that way I can line up my equal signs and make sure that I'm balancing my equation. The goal is at the very end of this to have your variable all by itself on one side and the number on the other. And that right there gives it away. It tells you what that number in that box has to be. So that's what we're looking to do. So with this question, it's how do I get the x all by itself? I need to isolate the x, isolate the variable. So we use inverse operations to do so. If I have this x plus 2, negative x plus 2, the first thing I always eliminate is whatever is being added or subtracted to that variable expression. So the variable expression is this negative x, so it's being added to it a 2, so the opposite inverse operation would be subtract 2. So I'm going to subtract 2, and I did it to both sides of the equal sign, so that way I'm balancing my equation. What do I do to one side? I do to the other. So what happens? Well, if you have a plus 2, minus 2, those would actually then cancel out. They're done. Those things zero out. And all that's left on this side is just that negative x now. So I just have to do the math on this side, which is 4 minus 2, which is 2. Now I have this negative x equals 2. So really all this is saying is the opposite of x is 2. So what does x have to be? The opposite of 2. But if we were looking at the operation to make this true, I'll show you that. This is a negative 1x. Every time there's a no number in front of the variable, it's that invisible 1. We can rewrite that 1. What is that negative 1 doing? It's being multiplied to that x. So, the inverse operation in this case, inverse operation of multiplication is division. So I would divide by negative 1 both sides. Because negative 1 divided by 1 is the positive 1, right? That's what we wanted. We want the 1x all by itself. And then 2 divided by negative 1 is negative 2. So really, I'll just write down here, x equals negative 2 is my final answer. So if I would put in a negative 2 back into my little box up here, would that be true? Negative 2 plus 2 is 4? Yes, that is true. All right, so I'm going to go a little quicker here on solving these, but I want to make sure you see that the process is just that. Get that x alone. So 4x minus 2, I'm on B, plus x is equal to 2x plus 8 plus 3x. So draw my equation line down the middle so that way I'm keeping things equal. So over here, we didn't have to do any simplifying. We started just eliminating things from both sides in order to get my x alone. Before I do that eliminating, though, I do need to simplify first. So simplify each side first. So in this case, 4x and 1x is 5x. So now I have 5x minus 2. That's all simplified. On this side, I have 2x and 3x. So that's 5x as well, 5x plus 8. So I've got an interesting situation here. I have 5 times a number minus 2 equals 5 times a number plus 8, and I need to figure out what that number is. Well, there's a problem here already, because if I'm looking to get my x by itself and isolate my x, I have to get all the x's on one side. And when I do that, if I subtract 5x from this side and 5x from this side, they actually cancel themselves out. So what just happened? What's left with is negative 2 equals 8. And that's not true. Negative 2 doesn't equal 8. So if I go back and I'm like, what happened? If I think about it, remember the whole thing about the equation was 5 times some number minus 2. When does that equal 5 times some number plus 8? So if you look at this, if I'm trying to think of any number that I would multiply by 5, that same number, and one side subtract 2, the other side subtract 8, that'll never be equal. Because there's no way you can actually subtract 2 from the same thing and add 2 from the exact same thing and add 8 from the exact same thing and get the right balanced equation. So that being said, because we're in this situation here, this is one of those places where we would say that x has no solution. So there's no number that x can be. So x has no solution, or x cannot equal any number. Okay, that's B. C, 4y minus 9 plus y equals 6. Again, bring down my equal sign, my barrier. First step is always simplify. Well, this side 6 is simplified as possible. This side over here, I can combine like terms. 4y and 1y makes that 5y minus 9 equals 6. So again, the goal is to get my y all alone. Y equals a number. That's what I'm looking for. I want my y, I want my variable on one side by itself with the number on the other side. So I have to eliminate the operations that are occurring to that variable. The first operation I always eliminate is either add or subtract. And I see I have a minus 9, so I'm going to do the inverse operation, which is add 9. Minus 9, add 9, cancels it out. But what I do to one side of the equation, I got to do the other. So now I have, what's left over here is 5y is equal to 15. So at this point, you might be able to see it. 5 times something is 15. 5, right? So again, it's this whole 5 times something equals 15. What do I multiply 5 times to get 15? Well, if we still don't see it, we can always use inverse operations. Opposite of multiplication is division. So that divides out, becomes that 1y, which I want. So I have y is equal to 15 divided by 5, which is 3. So I just solve for y. So y equals 3 on C. Okay. And last one, D. D, we have 9 minus quantity 2 minus 3y. That's on one side of the equation. The other side is 6 plus 2y minus quantity 5 plus y. All right, so it looks like I've got some simplifying on each side to do first. So this side, we need to simplify, combine like terms. But before we do that, we have parentheses with a quantity expression inside, and I'm subtracting all of that. So this is where, if we were looking at our algebra tiles, we would move things on the expression mat up, and it would flip over our tiles, right? So this case, we're going to say 9 minus, it's the opposite, so it becomes minus 2, and then opposite of minus 3 is plus 3y. So the other way to look at it is you're distributing this, right? It's a minus or a negative distributed through. So distributing to the 2 makes it, you could say, plus a negative 2. And distributing to the negative 3, right? When you have a plus, you can make it plus a negative. Or excuse me, when you have a minus, you can make a plus a negative. So distributing the negative makes it a positive 3. So I can keep going. I can now combine like terms. The terms I can combine are my numbers, my constants. So I have 3y plus 7 on this side, right? So that is simplified here. let's do the same thing over here. Again, first of all, we've got this set of parentheses with a minus in front, so I have to distribute that minus through. So on this side, it's going to be 6 plus 2y minus 5 minus y, right? Because it's minus 5 and minus y. Because it was originally a plus y, so now it's a minus y. It's the opposite. It does the opposite. So if I clean this up, 2y minus y gives me just 1y, right? This is a 1y, 2y minus 1y. And then 6 minus 5 is positive 1. So now I have 3y plus 7 equals y plus 1. And again, our goal is what? Get the y on one side with the number on the other side. So right now I've got y's on both sides. So I need to get rid of them on one of the sides, move them over, right? And on our equation mat, we would shift it over the equation line, and what would happen? We would flip it. So flipping it is the opposite. So I'm going to move this over by flipping it. It's subtracting y from both sides. So it's taking this y, removing it by doing the opposite, which is this is a positive 1y. I'm subtracting 1y. And when you move it over, it becomes the opposite. It was positive over here. Now it's negative. So 3y minus 1y gives me 2y. So now I have 2y plus 7 equals 1. So do the same thing now. Get the numbers all on the other side. So I'm going to subtract 7 from both sides. And that 7 minus 7 cancels. So I'm left with 2y equals negative 6. So you might see it already. Remember, now I'm saying 2 times something equals negative 6. But if you don't see it yet, that's all right. I wrote this too soon. Let's rewrite my equation so I can have some room. The next thing is if that's 2 times y, I've got to divide both sides by 2. So that cancels. I'm left with y all by itself equals what? What is negative 6 divided by positive 2? It's negative 3. So what I discovered that y equals negative 3 in order to make this original equation true. Y equals negative 3 in order for all of that to be a true statement. All right, there we go.